So, hello everyone, this is Gulshan from BSMS third year, and I will be presenting my project on handwritten digit recognition and with a live video demo. So, let's start with the how computers see images. Computers see images as a grid of numbers. So, then we have pixels. So, each pixel holds a number from 0 to 255, and the pixel which has number closer to 0 appear to be black, and the pixel which has number closer to 255 appear to be white, and between them, between black and white, the color appear to be gray. And for the color image, it mainly have three channels: red, blue, and green. Now let's see the dataset. So I'll be using a MNIST dataset for this project, in which we have 70,000 handwritten images of number 0 to 9, in which 60,000 images. I'm using 60,000 images for the training and 10,000 images for testing. And each image has a dimension of 28 into 28 pixel. And now let's see how the CNN works. So CNN is a convolution neural network, and it takes information from the images. Mm, mm, like there is a 28 by 28 image, and it takes a pixel from this image, and it extracts. So first we have a convolution layer. So what does a convolution layer do? It extracts some feature like edges and shapes from this part of the image. And then we have pooling layer. So pooling layer will uh, reduce the size of the feature map, and extract all the information which are needed to predict that image. Then we have convolution layer, then we have pooling layer. So what is happening is, uh, I have some feature of this image, then it gets reduced, then I'll extracting feature from this layer, pooling layer, and then it get reduced. So lastly, we have dense layer. So what dense layer do is, it connects all the neurons of this from this layer to this layer, and it also gets decreased, because we want 10 neurons for each classification from 0 to 9. We have 10 classes, so we need 10 neurons at the end. So it get decreases continuously. Then let's start with how I code the how I coded this project. So first we install some libraries like TensorFlow, OpenCV, and Matplotlib, and these are necessary for this project, as TensorFlow helps building neural networks, and OpenCV helps in pre-processing of the images, and Matplotlib is useful for visualizing the data like plots and chart. And also there is a NumPy which handles the numerical operations. Second, how to load the image dataset. So when we download the TensorFlow, the image dataset already downloaded with it. We don't need to download it again. So we can just uh, mm, take the dataset from the TensorFlow using Keras. Keras is a module inside the TensorFlow, and we can access image dataset from the Keras. Then we are the uses of matplotlib. How can we use that matplotlib? So it's just importing. Then we load some image from the training data set, and we can uh, decide what the color it has. So in this it is gray, and we can also give it a blue and green color. Then we are normalizing the pixel value. So what normalization mean is, as we know, the pixel contains the number from 0 to 255. So what does normalizing do is it convert the number from 0 to 255 to 0 to 1. So it helps us to predict the number accurately, and it is faster than the 0 to 255. And this is the code for normalizing the dataset, which is this. And this is the extrain, means the training dataset, and this is the testing dataset, and we are normalizing both of them. Then we are reshaping for CNNs because our image is in this array. Like this is a 3D array, but the CNN expect us to give it the information in the 4D array. So we will reshape it to a 4D array by this. In this, we are just specifying the size of the image and reshaping the training and testing dataset with minus one. Minus one means the last number of the dataset, which is 60,000, and the image size is the width and the height of the image, and the one is for the number of the color. So as we are doing it in a gray, so for gray it's one, and for the color image it should be three. Then let's see the construction of CNN architecture, which I am using for to predict the image. So first we have to import the models and layers from TensorFlow, and the layers like dense, dropout, activation, flatten, and convolution, and max pooling. So let's see how these layers and what does this layer do. So the dense, what does the dense layer do? As we know, it just connect the neurons from the previous layer to the current layer, and dropout layer prevent the overfitting. Activation layer helps the model to learn the complex pattern. Flatten does the it converts 2D, it converts the feature map to 1D, one dimension. And the convolution layer is just a feature extractor layer, and the max pooling is it reduces the size of the feature. So let's see the architecture. First we created a model, empty model, so we can put the layer into it, and we are using three convolution layer, which is this, and one flatten layer, and three dense layer. So what these three line of code do is, first the convolution layer extracts some features, then activation function will helps him to learn non-linear patterns, and the max pooling is to reduce the size of this feature map. Then we will repeat it for two times, and then we use the flatten layer to uh, convert the feature map to one dimension. Then we have dense layer, which and has 64. This dense layer has 64 neurons, and we are using activation function. Then we are using a dense layer with 32 neurons. Then we are using a dense layer with 10 neurons. So why we are decreasing these number of neurons is, as we know, we are using a MNIST data set in which there is a 10 classes, like from 0 to 9. Each number is a class. So we need 10 neurons for each of the classes. So we need to do it. And lastly, we use the activation function softmax to predict the probability, the number. Then we are training, and first we compile the model using this code, in which this is for the loss function. And what is loss function? Loss function is how far our predicted value from the actual value, and using a optimizer Adam and measuring the accuracy. then our model is ready to train. So we are training our mm, data set and predicting its label, that is by train, and we are doing it for 5 times, and the validation split is 0.3, means the 70% of the data is for training and 30% of the data is for testing. So this is the test performance that I get, in which uh, the this will go uh, to the training data set about 5 times, and you can see each time the accuracy is increasing because each time it's learn and reduce the loss, and this is the validation accuracy, and this is the validation loss. As and this 1313 is appearing because it goes in a batch size. Each batch size contain 32 images. If we multiply 1313 to 32, it's about 42,000, and which is our 70% of the uh, training data set. Now, how the video works. Now I'll explain how the video works. So first, we are importing some libraries that we see in that is TensorFlow, Matplotlib, or NumPy. Then we are tries to open the uh, video, which is with this code. So first, this is CV2 is OpenCV, that is also a library which help in processing the image or videos. So it opens the video. So this line means if this video doesn't open, so it will open the webcam. If webcam also doesn't open, it will show error. Now, so what am I doing is I am recorded a video. What I do is I recorded a video with a number that I have drawn, and I'm predicting those number in that video. So these lines are for uh, that I am fixing the width and the height of the text uh, that are predicted. So if let's suppose there is a two in a video, so I fix the width and height of the two which which is going to predict, and 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 fixing the horizontal and vertical position, and this is for the rectangle that I am going to create to hold those predicted numbers. Then we have this while loop. This is just a pre-processing of the predicted image, in which uh, this means there is an infinite loop which runs frame by frame, and this center counts the frame. So if center divided by 2 is equal to 0 means why I am doing this? This means ki it will go to every second frame to so the load on the CPU and GPU gets going to decrease, and the mm, that will fasten up the process. And then just going to pre-processing the predicted image. In this we are just uh, converting color image to gray image, and then we are resizing it, and then we are normalizing it, then we are reshaping it so the CNN can read it, and then we are predicting the image that I'll be creating on the video in the video, and then we are just then we also just we also can uh, give a probability of the predicted image. So, as you know, I'll be creating a rectangle in which the predicted text will be appear for the image that I'll be creating. So, in this, I'll just fixing the uh, image of the rectangle, which is the upper left corner, and the color of that uh, rectangle will be black, and the appearing text will be red. Or so so this is showing the video, and the wait key 2 means it will wait for 2 milliseconds if I breaking or uh, doing something, and if I'm not, then it will goes to the other frame, the next frame. And this is for breaking the loop, which is Q. So then I'll just closing all the windows, which is destroy all windows in which the CV2 is working, so the memory space can clean up. So this is the PPT, and now I'll showing the code. So this is the code in which first I'll importing the TensorFlow, then uh, loading the image dataset, and then specifying the training and test from the image dataset. And we can also check the shape of the mm, training dataset, which is 60,000, which is the number, and 2828 is the size dimension of each number. Then we are just showing any random image from the training dataset. Let's in this case, it is true that the third position in the training dataset, which is you can see is 4. And I'll just uh, uh, what am I doing in this key? Converting the color image into the gray image. So it will show the gray image also. So there is a gray image of the number from the dataset, training dataset. And then print extrain means I will be printing the pixel value of this gray image. So as you can see, there is a black in the upper right corner. So there is a 0 on the upper right corner. And so at the white there is a some values, so it is nearer to the 255, so it's appearing to be white. Then I'll normalizing the training dataset and test dataset, and then uh, showing the image, which is this. And if I'll check the print, if I'll check this code, now I'll see the there is a 00 and there is a 0.1 0.2. It is normalized, and the value of all the pixel became 0 to 1. Then just going to print the label uh, for the training data, which is 4. As we can see here, it is 4. Now what am I doing is reshaping the uh, training data and test data, so the CNN can able to read it, because as we know the shape of the training data set is this, and it is in 3D. This, so this is the shape of the training data set. So we need to uh, convert it into a 4D. So we reshape it, and there is a 1. This is for the color, which is the gray. So there is a 1, and we also specify the image size, which is 28. And now we are importing these models and layer to build the CNN model, a neural network. And as I explained earlier, this is the model, empty model, to add a layer in it. So we can add a layer in it, and it will. So this is the CNN architecture, and now we can check the model summary here. So for the first layer, convolution layer, this is 26 into 26 is the image size, and 64 are the neurons. And activation layer does the just helps to learn the complex model. And the max plane layer, what max plane layer does is it reduces the size to, so it reduces the size from 26 into 26 to 30 into 13. So it gets half of the size due to the max spring layer. Then we have second layer, and it became 11 by 11. This decreases because the output image size is equal to input image size minus filter plus 1. So the filter is 3. So it's reduced by this. And we can see it get reduced 5 into 5 due to the max pooling layer, and then uh, to 1 cross 1 due to the third layer max pooling. And then we have dense layer with 64 neurons, and it goes to 32 neurons, and it goes to 10 neurons. So for each neurons we have a class. And we can also print the total training sample, which is 60,000. Then we are compiling the our model, and the loss function we are using is this, the optimizer is this, the what we are measuring is accuracy. And now we will train our model about 5 times, and the validation split is 0.3, and these are the accuracies, valid accuracies, and loss and validation loss. And now I can also print the loss in the test dataset and accuracy on the test dataset, which is 0.05 is the loss, and validation accuracy is 98%. I can also predict the testing dataset. Now I'm printing the now I am printing the predictions, which is the probabilities of the numbers in the testing dataset. Test data. And you can see here is a 9.9. So this is the highest probability in the first row, and we can know whose probability is this. So just by printing by this line, we can know that this probability is of 7, and we can also show the image of this. And we can also show any image of the test dataset. Now like 129th image is 8. So let's now I am importing the OpenCV. So what OpenCV do is it treats the image which I have uploaded. So I uploaded this image of it, and uh, it is just showing the image. And now I can know the shape of this image, which is this, and convert it into a gray image. So this three will convert into a one, gets converted into a one, and then we just pre-process these the image by now we are doing this resize and normalize and reshape this image, and finally we get this. This is the uh, shape of the image, in which there is one number of the image, this is the dimension, this is the color of the image, and here what we are doing is predicting the image that I have uploaded is 8, which is correct as I uploaded the number 8. So now for the video part, I have uploaded all these libraries, these for the this for now, and I am also specifying the font size. And here I am opening the video. If it doesn't open, it open the webcam. If the webcam also not open, it will throw an error. Here I am fixing the size and width of the number, which is in the triangle, which is in the rectangle, and this line is for creating that rectangle, and this is for fixing the horizontal and vertical position. And this is just the pre-processing of the the image that I'll be drawing on the in the video, in which I am doing resize, normalizing and reshaping it, and predicting the image. And here I am fixing the uh, place for the rectangle, which is the upper left, and the background color of the rectangle, and the color of the predicted text which is in the rectangle, and here I'm just uh, opening the video, and this is the code for the video. So I'll be running this code and showing you how the video works. Now what I did is I'll just run all the cells, so it will going to run all the cell where mm, these are the result from this code and so on. These are the pixel, this is the gray image, this is the normalized pixel, and these are the dimension of the text, test and training sample. And this is the CNN architecture, this is the model summary, and here it is training our model, which is you can see is running from 0 to 1313, and giving us the accuracy loss, and it will be giving us a validation accuracy, that is this, and the validation loss, and it will do this for 5 times, so the accuracy can increase or loss can decrease. So I'll be just pausing this. As you can see, the model is trained and the accuracy are there, and now it is going to giving loss and accuracy in the testing test data set. And these are the probabilities, and this is the probability for this highest uh, probability. Highest probability. This is the number for the highest probability. And now the for the video part. Video part. I will be showing a video which is like this, in which I will be writing a number, and there will be a predicted number on the upper left corner. First is 0. Now the second one is 1. The third one is 2. And now it will be 3. And now 4. Now it's time for 5. Now there will be 6. It will go up to 9 and predict all the numbers. It is 8. And now the last one is 9. So this is the video. Thanks.